Welcome to Miss Taylor's class notes. So today we're talking about the triangle midsegment theorem. So a midsegment of a triangle is a segment that connects the midpoints of two sides. So if we're looking at this example here, M is the midpoint of AB, P is the midpoint of BC, and so MP is our midpoint. And then N is going to be our midpoint of the other side. So PN is another midsegment, and then MN is another midsegment. And these create a midsegment triangle. So it's a triangle inside a triangle. So that's what a midsegment is. Now let's talk about what we know because of our midsegment theorem. So if D is the midpoint of BA and E is the midpoint of BC, the first thing that we know is we know that these two lines, that DE and its base, are going to be parallel. And if they are parallel, there's some key things that we need to remember from, I believe it was Unit 3. So if line DE is parallel to line AC, then we have our transversal, which cuts across two parallel lines. And if we have a transversal that cuts across two parallel lines, our corresponding angles are congruent. So corresponding angles are congruent. So angle BDE is congruent to BAC. You could also name it DAC. They are the same thing. The other thing that we know is we know that our consecutive interior angles, so this angle right here and this angle right here, equal 180 degrees. Consecutive interior equal 180 degrees. And then if we look at the other side of our triangle, BE, we have another set of corresponding angles. So angle BED would be congruent to angle BCA. And then we would also have another set of consecutive interior angles that equal 180. So the last and final thing that we know is we know that our midsegment, DE, is half of AC. And this is the same thing as saying that 2 of DE equals AC. All right, so I'm going to go ahead and talk about it and mark up the triangle, and I want you to write down the statements that I say. So if we know that A is a midpoint, we know that GA is congruent to AH. If we know that B is a midpoint, we know that HB is congruent to BJ. If we know that C is a midpoint, we know that GC is congruent to GC. The next bit of information we know from the triangle midsegment theorem is we know that that CB is a midsegment, we know that CB is going to be parallel to HG. We also know that AC is parallel to HJ. And then we also know that AB is parallel to GJ. And then the next thing that we know. So we know that BC is 1/2 of GH. So we know that 1/2 of GH is the same thing as GA because A is our midpoint. So we know that GA is congruent to AH is congruent to CB, which means we know that AC is congruent to HB is congruent to BJ. And then we know that AB is congruent to GC and CJ. And we also know our parallel lines and our corresponding angles. So let me mark those as well real quick. So if these two are parallel, we know that this angle is congruent to that angle. We know that this angle is congruent to this angle. We know that if these are my parallel lines, I know that this angle is congruent to that angle, and this angle is congruent to this one. And then if those are our parallel lines, I know that this angle is congruent to that one, and that one is congruent to that one. And so that's all of the information that we know by simply knowing that A, B, and C are midpoints of our triangle. I'm going to skip this one for now because it's going to make the video pretty long, but you can go look at the completed notes to understand how we can prove using a graph that these parts of our theorem are actually true. All right. So DE is a midsegment. So that means that this is congruent to this. This is congruent to this. We know that these two lines here are parallel. I know that this angle is congruent to this angle is congruent to that angle. We also know that DE is 1/2 of BC. So DE equals 1/2 of 26. So DE equals 13. Again, same thing. Midpoints, midpoints. Parallel, parallel, congruent angle, congruent angle, congruent angle, congruent angle. So we know that EC equals 6 because our point E is the midpoint of AC. All right, A, B, and C are midpoints. And again, you can go look at the triangle on the previous page because it's the exact same triangle as this one. So they're telling us that AC and HJ is what it gave us. So we know that AC equals 1/2 HJ. So now we can plug in our numbers and we can solve. Now, real quick, whatever HJ is, we're going to put it in parentheses because we need to distribute this 1/2 to both of those terms. And I'll always remind you guys that multiplying by 1/2 is the same thing as dividing by 2. So 4 divided by 2 is 2, and 2 divided by 2 is 1. So we subtract the y's, we add the 5, and so y equals 6. But let's look at what the problem is asking for. Our problem is asking for HB. So HB, we said, is the exact same thing as AC because AC is 1/2 of HJ, and we know that HB is 1/2 of HJ as well. So we're going to plug this y equals 6 into AC. 18 minus 5 should be 13. So AC is 13, which means that HB is also 13. All right, now they gave us AB and GJ. So we know that AB equals 1/2 GJ. So we're going to plug in our numbers. Again, everything that is GJ needs to go in our parentheses. Multiplying by 1/2 is the same thing as dividing by 2. So we get 2x equals 4, x equals 2. Ooh, let's write numbers correctly. And then we want to find AB, so we're going to plug 2 into AB. So 6 times 2, 6. Where did I get? Oh, I did the math in my head already. So 6 plus 8 is 14. So AB equals 14. All right, so our last one, GH and CB. So we know that CB is 1/2 GH. Now I'm going to real quickly remind us, we can also change our equation to look like this. And if we change our equation to look like this, the CB is what needs to go in because multiplying by 1/2, the opposite of it on the other side is multiply by 2. So now we plug in our numbers. So we need to make sure we distribute. And I typically only do this formula when what I would divide by 2 would get me odd numbers and get me decimals. I don't like to deal with decimals. I'd much rather deal with whole numbers. So that's why I did that. So I'm going to subtract 7z, which leaves me with z. I'm going to add 6, which equals 5. The problem's asking for GA. GA is half of GH, or it's the same thing as CB. So I'm going to plug this into CB. So 4 times 5 minus 3. So 20 minus 3 is 17. So GA equals 17, which is the same thing as CB. And that is how we use our mid-segment formula. Theorem, not formula. Mid-segment theorem.